Hello, this is Dylan Moore. This is for CPSC 4550. This is Lab 4, Part 2. And this is going to get into the DHCP section. So we'll start off with question 1. I've already got my trace file over here pulled up, and I've got a lot of my important packets that I need. I've already run my command prompt commands, all my ARP commands to get those registered on the trace. And so we'll get started with question 1. It says, are DHCP messages sent over UDP or TCP? And they're sent over UDP because you don't see TCP show up over here at all in this window. You do see UDP though. So it shows you right here it uses user datagram protocol instead of TCP. And then the next question is, what is the link layer address of the host? So the host is me, or my computer. And so if you look right here, dynamic host configuration protocol, come down here, host name Archibald, and you can also find the address because this is my address. And we're looking for the MAC address, and I'm the client, this is my machine, I'm the host. So that MAC address is F4463782B2A7. And then we move on to question 3. What values in the DHCP discover message differentiate the message from the DHCP request message? So if we look at discover, and we'll go ahead and look under the same transaction ID. But basically it comes down to the options down here. And you've got your discover and request. And if you look, the options change for each one. So discover, first off, we've got option 53, we've got an option 53 down here. But the difference is this is classified as discover. And if you look, it's got DHCP discover 1. If we go down here to request, it's got DHCP request 3. So there's some differences right there, and it changes that. And there looks to be some differences in other options as well. Looks like we've got, under discover, we've got 53, 61, 50, 12, 60, 55, and 255. And in request, we've got 53, 61, 50, 54, 12, 81, 60, 55, 255. So it looks like option 81 option 54 81 and 54 are going to be the ones that are different. So we've got client fully qualified domain name there, and DHCP server identifier, which leads us down to our next questions. What is the value of the transaction ID in each of the first 4 discover, offer, request, ACK DHCP messages? And if you look, we got a discover, offer, request, ACK right here. It's got the transaction ID over here. And that transaction ID is 0x89DD0159, and it's the same for all 4 of these because these have to do with the same request. So all of those will be done. They'll be in the same field, and it's really so that clients and servers allows clients and servers to match responses with requests. And that's kind of the big deal with the transaction ID. And so let's go to the next question. And if you look at the values of the transaction ID in the second set of request ACK set of DHCP messages. So we got request ACK, so our second set of request ACK messages is 0x2579EFAA, and those two are also the same from the request to the acknowledgement. Just like the first request and acknowledgement have the same transaction ID, because they all have to do with the same request. And then if you look at release, it's just one. There's no response for that. It just releases it, resets that IP address, and that's pretty much it for that. And then let's see, a host uses DHCP to obtain an IP address among other things, but a host IP address is not confirmed until the end of the 4-message exchange. If it's not set until the end of the 4-message exchange of what values are used in IP datagrams in the 4-message exchange. And it says for each of the 4 DHCP messages indicate the source and destination IP addresses that are carried in the encapsulating IP datagram. So if we look, you can see your IP addresses that are being used here, and we'll start with Discover. And Discover shows you that there is no IP addresses associated. They're all 0000, so they're not set yet. And so next what happens is there's an offer made. The offer's made, and then this is going to be my IP address and the next server IP address. And so DHCP server identifier, so DHCP server IP address, so yeah, those are all set to 0. Down here shows my IP address, which is the source, and the destination is going to be 192.168.1.1. And then if you go down to this one, it's still the request, and there is no IP addresses. It's still all set to 0. And then if we go to the acknowledgement at the end, you've got your IP addresses set. This is showing mine, 192.168.1.125. And this is also where you can tell. You go up to the IPv4, and you can see source address, destination address. So the source is 192.168.1.1. Destination is 192.168.1.125. And we'll start up here again. Discover. Source address not listed because we'd had it released. It's been reset. It was set to 0000. Destination address, we're still searching for that. We're trying to discover that. Goes into the offer. Source address is set. That is 192.168.1.1. As you can see, that's changed. And then the destination is my IP address. This is the offer coming back. And then the request is sent back out. Source address 000, it's unset. Destination address also unknown yet. We have to find that. And so then the message is acknowledged, and the source from the source, which is 192.168.1.1, destination 192.168.1.125. So those are those IP addresses. And it says, what is the IP address of your DHCP server? You can find that down here. Let's see. Let's go ahead and minimize all of these. DHCP server identifier. This shows you your DHCP server, which is 192.168.1.1. And that's where you can find your DHCP server IP address. And then question 7 is, what IP address is the DHCP server offering to your hosts in the DHCP offer message? This is the offer. An IP address that it is offering is broadcast address is 192.168.1.255. So that's the one that it's offering. Now we go to question 8. In the example screenshot in this assignment, there is no relay agent between the host and DHCP server. What values in the trace indicate the absence of a relay agent? Is there a relay agent in your experiment? If so, what is the IP address of the agent? So if we look, you can find relay agent IP address. That's 000, so that one hasn't been determined, and that's under any of these. There isn't a relay agent IP address. So there isn't one that's used in this, and you can find that right here. Explain the purpose of the router and subnet mask lines in the DHCP offer message. So we go to the offer message, and we can look down here at the router. And the router is the gateway for anything going in or out from an outside network. So this is going to be the IP address that's used for that, for anything that goes in or out of this particular network. And the subnet mask is going to be the range of IP addresses on the subnet that my machine is on. So it gives you your range right here, which is a pretty big range of things, but that's what that is and how you can find that. It says explain the purpose of lease time. So the purpose of lease time is that this is the amount of time that you're going to get this IP address. After lease time is up, that IP address expires and it goes back to be used somewhere else. And if you look, option 51, IP address lease time, it says IP address lease time is 2 hours. So we have 2 hours for this experiment in lease time. And question 11 is, what is the purpose of DHCP release message? The release message allows that IP address to be used somewhere else. It says where I'm done with it. It sends it back to the server to where it can be used somewhere else for something else, for some other thing. And it doesn't issue an acknowledgement of the receipt of the client's release request, because I guess it just does that. It just goes. Once you hit release, it's released and it's sent back. But if that message is lost, then you just have to wait for that release for that for that lease time to run out. And once the lease time runs out, that address will return. But if it's lost, even if it's not being used by you, it won't be able to be used anywhere else until the lease time is up. Now it says to clear the boot P filter from your Wireshark window. So we're going to clear that. And here is all of our let's see. Let's go boot P. Make sure we got our packet numbers 472. So here we are. We still got our DHCP. And it looks like there are some ARP requests. Here. And but it's not looking like so we released DHCP. Let's go down. Okay, so here's our discover offer request acknowledge, and we go to source destination IP addresses. But it's gonna, the ARP is supposed to connect IP addresses with Ethernet addresses. So as you can see, we sent out the discover message. And it sends out the ARP request. It says who has 192.168.1.1. You need to tell 192.168.1.1.25, which is me, which is my computer. And this is our gateway IP address, and this is my computer's actual IP address. And then it returns my gateway there to it returns my gateway's MAC or Ethernet address. So there are ARP requests involved with the DHCP messages, because that is how we're finding our MAC addresses and our Ethernet addresses. And I think that covers part 2 of Lab 4. Thank you.